This is Module 2, Lecture 2 on Research Design and Data Management. In this lecture, we will go over again the process of performing research and discuss a little bit the major reasons for faults in research proposals. And of course, we begin here in thinking of research, coming up with a research idea. We browse, converse, and think, and then go to step 2. The idea sprouts what if, what does, to number 3. Narrow down what do I want to do, getting to your specific aims, goals, objectives, aims. Formulate clear, specific questions to lead you to your hypothesis. And number 5, determine why the answer might be important. So there has to be a significance. So in essence as well, the background and significance formulating of your hypothesis, at least superficially. And then 6, surveying the relevant literature. Let's back up and follow some of the pathways on these. If we get to number 3, narrowing it down, what do I want to do, and decide if it is still worth pursuing A. If not, of course, we go back to the very beginning. If yes, you proceed to the next. And from there to number 5, we sprout out to this question. Is the importance of the question now clear? If yes, we proceed then to the more extensive survey of the literature. From the extensive survey of the literature, can we find that a clear answer is provided? If yes, the answer is well known, then if yes, that the answer is well known, already published, you have to go back and refine your thinking to come up with a unique idea. If the clear answer is not provided, the no, then proceed to number 8, intensive review of the literature. If you proceed from that to determine why it's clear that there is no answer, then you may have to go back to the literature if there is no clear answer. But if there is a clear answer, then is the reason for no answer remediable? remediable? If no, of course, you go back. So if it's simply an impossible project, you end up back at the starting point. We are now then also considering that if there's a reason for no answer and it is remediable, then we consider alternative forms of the inquiry and go on out to ask the question, is one most appropriate? If yes, we come back in, and at the next level we rough out the design of the study. Sorry. So we are at number 10, roughing out the design of the study, and 11 is picked up on the next page. We consider alternative methods of measurement and shoot on out to ask this question. If is one most appropriate? No. We go back in and of course keep working on things until we get a yes response. We consider alternative methods of analysis, go out and ask a question, is one most appropriate? If no, we go back and keep working on it. If yes, you proceed to number 13. Review and refine the design. Go on out in that process, asking the question, the meaning of all possible results, are they clear? No. You go back and you keep working on design, making sure that your design is actually testing your hypotheses. And of course, at any one point in time, if things get faulty, you go back to some of the earlier stages to make sure that you have pulled from the theoretical framework, identified an appropriate gap, asked the right questions, generated the appropriate hypothesis, and run through the design again to get back to this point. If your design is doing everything that you want to provide clear results that have meaning, you can draw direct conclusions, And you specify all procedures in detail in the experimental design and methods. You prepare the first full draft. You share and discuss with colleagues and your advisor. If this question is asked, if there is a significant flaw revealed, and the answer is yes, you return to appropriate step between 8 and 14 to remediate, if you can. If no, if there's no significant flaw, then you conduct the pilot studies, analyze data, and review all procedures. Come out and ask this question: substantial problem encountered? If yes, you're back up to the earlier time points to find out what you can do to remedy that. If no, you're back into the system here at number 18. You prepare the revised draft proposal. You present to your committee, explain and support. Come out, ask this question: significant revision required? Yes. You go back a step and cycle back through. If yes, then you gather all your data, complete all your experiments, process and interpret as planned in the proposal. And you also take into mind that this is a general scheme, and that it is a working process. This box basically just describes the procedure to get through this outline. This is no news to any of us, I'm sure, but what you might be surprised about is how far along the way the pilot study occurs. Quite often we're pushed to the bench and collecting data before we have completed all the prior steps to this point. If you find yourself at the bench because you're in a training situation, be sure that immediately you go to the idea part of it, attending lab meetings, asking questions, get into the literature and work your way up to this point to understand what you're doing, why you're doing it, begin to integrate it into your ideas for your research, or to understand the research that you're involved with. And this figure from our text describes the inductive process. We have separate and individual facts provided by the researcher, 1 through 10, and they bring us to this one point. They all seem to lead to a single conclusion, and this almost looks like the theoretical framework of all the facts and our one point that goes back in, but this is of course showing all of your specific aims or objectives collectively for your problem and subproblems, and everything leading to support of your theoretical framework. So it's actually the opposite. This is our contribution to the theoretical framework that emerges ultimately from all of the research data, substantial conclusions that we generate. In this figure, we are considering the basic format of the research process. Continuing with that, it captures the basic steps in a quantitative research design. In qualitative designs, most of these steps are still included, although they are likely to be ordered differently. For example, the literature review may occur after the researcher has gathered and analyzed information related to the question. So at number 1, the question is posed. In the mind of the researcher, a question arises that has no known resolution. Step 2, it's a matter of words. The researcher converts the question to a clearly stated research problem. Step 3, it's worth a guess. The researcher proposes a temporary or tentative hypothesis or series of hypotheses. 4, the search is on. The literature is searched for a possible solution to the problem. 5, the search leads nowhere. Another avenue must be found to resolve the problem. This unfortunately can happen all too easily, so we need to be very careful, especially, as I said, if you find yourself at the bench and you haven't gone through steps 1 through 5 yet. Step 6, data, hard data, and nothing but the data. The researcher looks for data that may relate to the problem. 7, what do the data say? The data are subjected to analyses to reveal their meaning. 8, the data speak. The researcher comprehends their meaning and suggests a conclusion. 9, it's either or. The data either seemingly resolve the research problem, support the hypothesis, or they do not. They do not resolve it. And the hypothesis, either the data support the hypothesis or they do not. So answering or dealing with the problem, you identify the problem and subproblems, as you recall in another discussion of this approach to research. You have to see if you've solved the problem and then get right down to the point. Do you support your hypothesis? If it is supported, you put it back into the theoretical framework. So now, what might be some of the weaknesses found in proposals? This is from table 6.1 of our textbook, in a study of 605 grant applications disapproved by the NIH. So class 1 problems showed up in 58%. The problem is of the problem, the research problem identified, statement of the problem, is of insufficient importance or is unlikely to produce any new or useful information. About a third of them in this class fell into that situation. The proposed research is based on a hypothesis that rests upon insufficient evidence, is doubtful, or is unsound. So a poorly improperly stated or poorly developed hypothesis, close to 10% there. The problem, the research problem, is more complex than the investigator appears to realize, so taking it too lightly. The problem has only local significance or is one of production or control or otherwise fails to fall sufficiently clearly within the general field of health-related research. If you're submitting to National Science Foundation and proposing clinically or health-related research, you might be rejected. On the other hand, that it is health-related and should be submitted to NIH and will be rejected by the National Science Foundation in virtually all cases. So you see that this percentage is decreasing as we're going down through these class 1 problems with them. Don't confuse this. This is based upon the research problem. Sorry. It's a problem with the research proposal, but and the problem are weaknesses, and this is weaknesses based upon the statement of the problem or the scientific problem. So it's scientifically premature and warrants at most only a pilot study. The research as proposed is over-involved with too many elements under simultaneous investigation, so too expansive. Remember, 3 objectives is the most, and just 1 to 2 at most specific aims per objective for a comprehensive 5-year study in many cases, 5-year project, excuse me. The description of the nature of the research and of its significance leaves the proposal nebulous and diffuse and without clear research aim. I'd seen in a colleague's review that there was no theoretical framework within which to fit the scientific problem or the outcome of the research if the aims were successfully achieved. Class 2 is based upon the approach. The proposed tests, methods, or scientific procedures are unsuited to the stated objectives. So remember that correspondence of problem to method to, I don't remember all the terms here, but problem to method to conclusion, basically. There has to be that one-to-one-to-one relationship. The description of the approach is too nebulous, diffuse, and lacking of clarity to permit adequate evaluation. Many of these you'll find they'll just say that the methods are poorly developed, the experimental design was poorly developed, and the methods were poorly written. The overall design of the study has not been carefully thought out. Statistical aspects of the approach have not been given sufficient consideration, and the approach lacks scientific imagination. So there's many different things that can be identified in a grant proposal as a weakness and reduce enthusiasm and lead the reviewer straight to rejection. Controls are either inadequately conceived or inadequately described, so you don't always assume that a reviewer understands the appropriate controls that you intend to include. You state the ones that you're going to include, and in the rationale make sure that it's understood why they are essential and appropriate. The material the investigator proposes to use is unsuited to the objectives of the study or is difficult to obtain. So might be reagents that don't exist, you're planning on developing them, and it's highly unlikely that you might within a time frame to successfully achieve the objectives and goals in the period of support or the funded year. The number of observations is unsuitable, so we'll talk about making sure that you have an appropriate N in sample size in future studies, in future lectures. The equipment contemplated is outmoded or otherwise unsuitable, so state-of-the-art is expected. Class 3 would be the investigator. The investigator does not have adequate experience or training or both for this research. So any one of these or any collection of these criticisms can be included in a review for a weak proposal that lowers enthusiasm and leads to rejection. The investigator appears to be unfamiliar with the recent pertinent literature or methods or both. Ouch. The investigator's previously published work in this field does not inspire confidence. Ouch. The investigator proposes to rely too heavily on insufficiently experienced associates. Ouch. The investigator is spreading him or herself too thin and will be more productive if he or she concentrates on fewer projects. So overcommitment or over enthusiastic about accomplishing unrealistic objectives in the time frame of a grant proposal period, especially important for dissertations and master's theses. The investigator needs more liaison with colleagues in this field or in collateral fields, need more collaborators. The requirements for equipment or personnel are or both are unrealistic. And under Class 4 Other, it appears that other responsibilities would prevent devotion of sufficient time and attention to the research, overcommitment. The institutional setting is unfavorable. Ouch. Research grants to the investigator now in force are inadequate in scope and amount to cover the proposed research. So this brings us to this table, the types of shortcomings in NIH grant applications for clinical research that fared poorly. So I'll just go through these without discussing numbers or percentage. So the types of shortcomings, the research problems: hypothesis ill-defined, lacking, faulty, diffuse, unwarranted; significance unimportant, unimaginative, unlikely to provide new information. Under experimental design, study group or control, inappropriate composition, number, or characteristics. We'll talk about these types of bias and troubles with experimental design in future lectures. The technical methodology, questionable, unsuited, defective. Data collections procedures, confused design, inappropriate instrumentation, timing or conditions, right there, and data management and analysis, vague, unsophisticated, not likely to provide accurate and clear-cut results. So we're going to take a look at research design approaches to try to minimize any type of criticism in these categories. For the investigator, inadequate experience or unfamiliarity with literature, poor past performance productivity on an NIH grant, insufficient time to be given to the project proposed, resources, inadequate institutional setting, support staff, laboratory facilities, equipment, restricted access to patient populations, insufficient involvement of co-investigators. Total number of shortcomings was 704 out of this group. The number of applications examined, 256. So the mean number of shortcomings was roughly 3 per application. So it doesn't take many, and sometimes even only one shortcoming to lower enthusiasm sufficiently for the reviewer to reject the proposal. Let's continue with this. The top 10 reasons proposals are turned down: inadequately presented statement of need perceived by funder as either a not a significant issue, or as one of such magnitude that a few grant dollars would barely make a dent in the problem. The objectives are ill-defined, put forward as vague goals or as personal aims. Procedures are confused with objectives. The lack of integration within the text among components of the proposal. The funder does not accept proposals from unaffiliated individuals, so you need to know the funding agencies from which you are soliciting support. The funder knows that the proposed idea has already been tried and failed. Ooh. The funder approves of the concept but believes that the applicant is not the proper individual to conduct the project, or that the institution with which the applicant is affiliated is not suitable. The individual has adopted a poor approach and appealed on an emotional or a political rather than a factual basis. The idea costs too much. The funder does not have enough information. So this concludes our lecture on matters related to performing research, getting geared up to write a research proposal, and anticipating the major problems that could come